In this lesson, we're going to be solving radical equations. So if we're given x minus the square root of x plus 11 equals 1, our first step would be to isolate the square root, or whatever the root is that you have, because we don't just have to have square roots, we can have cube roots, fourth roots, and so on. So in our case, we want to isolate that square root. So I'm going to move the x over first, and when I move the x over, that means I'm going to be left with negative square root of x plus 11 equals 1 minus x. I still have that negative in front that I need to get rid of, so that really is like a negative 1. So I'm going to divide everything by negative 1. So on the left, divide by negative 1, negative 1, negative 1, so that we can see that we're going to be left with the square root of x plus 11 equals negative 1 plus x, which you can keep that way, or I'm just going to reorder this. That way we have the square root of x plus 11 equals x minus 1. Our next step would be to get rid of the square root. Well, if you remember when we were solving quadratic equations using our square root property, if I had x squared equals a number, the way that I got rid of the x squared was by taking the square root. So same idea here is that when I have a square root, I'm going to be raising both sides to the second power. What you're essentially going to do is whenever you have a radical, you're going to raise both sides to the power of whatever the index of your root is. So if you had a cube root, you'd be raising both sides to the third power in order to undo that radical. So in our case, that means we're going to be having the square root of x plus 11 raised to the second power, and then x minus 1 raised to the second power. And what that'll do is cancel out our square root. So what we're left with then is x plus 11, the square root and the square cancel out, equals x minus 1 squared, which brings us to our next step, which is then to simplify this. So on the right hand side, I do want to work that out. So I have x plus 11 equals x minus 1 times x minus 1. So you're going to need to multiply this out, show your work for it, FOIL, however you want to do that. So that way we have x plus 11 equals x squared minus 2x plus 1. In this case, since we're given a quadratic, we can see we have an x squared. In order to solve for x, we would like to try to factor. In order to factor, we need to get the equation in standard form. So I'm going to move the x and the 11 over to get our equation in standard form, which means that I would be left with 0 equals x squared. Moving the x over, that would make this a minus 3x. Moving the 11 over, that would give us a minus 10. If you don't like the way this looks, you can put the 0 on the other side, so you have x squared minus 3x minus 10 equals 0. Either is okay. As long as you understand that we need to have it in standard form equal to 0. Once we have this, now we want to try to factor in order to finish solving. So I would have 0 equals, we want what multiplies to negative 10, adds to negative 3. Well, that would just be x minus 5 and x plus 2. Using our 0 property, we would have x minus 5 equals 0, x plus 2 equals 0, which would give us answers of x equals 5 and x equals negative 2. Now, at this point, I got these potential solutions because we are not done. We now need to check our answers back in the original equation. When we're dealing with a square root, remember in that second step, we raised both sides to the power of 2. In doing that, we might have gotten a false solution, one that doesn't work in the original equation. Because remember, when we square a negative, it'll make it positive. When we square a positive number, it'll also make it positive. So we might have gotten an answer that is not a solution to the original equation. So what we have to do is we must go back and look to see if it checks in the original. So you can most certainly use your calculator to help you check your answers. I will walk through the steps for doing this by hand. So we have x equals 5 and x equals negative 2. So starting off with x equals 5, I would plug this in as 5 minus the square root of 5 plus 11 equals 1. Well, 5 plus 11 is going to be 16. So we would have 5 minus the square root of 16 would be 4 equals 1. So we get 1 equals 1. This does make sense. So that means that x equals 5 is a solution. For x equals negative 2, we would repeat the process. So we'd have negative 2 minus the square root of negative 2 plus 11 equals 1. So we'll have negative 2 minus, negative 2 plus 11 is 9. So we're okay so far. I don't have a negative underneath the radical. But the square root of 9 is going to be 3. So then I have negative 2 minus 3 equals 1. Well, negative 2 minus 3 is negative 5. So negative 5 does not equal 1, which means that x equals negative 2 cannot be a solution. So we did all of that work, but we found a solution that did not work, which means that our final answer, our final solution is just 5. So be sure that you go back and check both of them in the original to determine if both sides are equal.